This is our lesson 12 on selecting a suitable storage device on computer systems. Remember, we are following the GCSE Computer Science OCR J277 specification. Now, before we move on to selecting a suitable storage device, let's recap on our unit of measurement. Now, you might say that why do we need to know this? This is just a recap because remember, when we are selecting a suitable storage device, we need to understand what are kilobytes, what are megabytes, what are gigabytes, what are terabytes, and what are petabytes. So you can pause the video and make some notes. So remember you can either use a 1000 or you can use 1024 and the examiner will accept that answer. So this is what we did in our last video. We talked about our devices. So hard disk drive types are magnetic. Their storage is uh, 500 to 8 terabyte, maybe more nowadays, and they cost low per gigabyte. Solid state drives have got 128. They start for 128 and they can nowadays go up to more than 2 terabytes. They are high cost per gigabyte. USB flash drives are also solid state. They can vary from 8 to more than 256 gigabyte nowadays. They are a moderate cost per gigabyte. CD, DVDs, Blu-ray disc are optical. Now remember the CD is 700 megabytes, their storage capacity. DVD is 4.7 gigabyte to 9 gigabyte and Blu-rays are 25 gigabytes to 50 gigabytes low cost per disc. Now, how do I choose the right device for the right purpose? Now, this is an very important question which comes in your exam, choosing the right storage device for the right purpose. So, what are the six things you need to look at? You need to look at the capacity, number one. Then you have to look at the speed. Number three is your cost. Number four is your portability. Number five is your durability. And number six is your reliability. These are the six things you need to remember when you're choosing the right device. So let's look at a scenario of which is basically we look at three scenarios. So let's look at number one. The army would like a new portable computer that can be used whilst in the field. It must be robust enough to withstand bumps and easy to transport to new places. Money is no object. Now, these are the sort of scenarios they will give you, and then you have to decide which uh, storage device is more suitable. So, as you can see, we have looked in our previous videos in detail regarding your magnetic, solid state, and optic. So, in this scenario, solid state would be most suitable. So, solid state, why? Because look, you have to read the question. The question is that it has to be portable and must be robust. So, a solid state device has a high durability, which means it can withstand any bumps or drops. It is small in size, weight, which is perfect for a device that needs to be portable because money is no object. A high cost is not a concern in this scenario. So let's look at the next scenario, which is to do with your school backups. A school wants to back up all students' work twice a day and keep it safe. In case of any emergencies, the cost of the device is very important. So, what is the main key? So, when you are doing these sort of questions, you can highlight them. So, what are they saying? They're saying cost of the device is very important as the school budget is tight. So, this is what they're saying: the school budget is tight, and they want a device that can hold terabytes. So, they want something which can hold terabytes. And also, what they're saying is that they don't want that many devices. They just want one. Okay, they just want one. There it is in your scenario. So you can highlight these. So in this scenario, a hard disk drive would be most suitable. A hard disk drive has the highest capacity and would limit the amount of devices they would need to buy. It is also important it is also relatively cheap per gigabyte compared to solid state. Reliability could be an issue, but as this is being used for backing up data, it will not be used constantly. So that can reliability can be an issue, and you might say, where did I get all these reliability, cost, etc.? It was on your third slide here, where the how to choose the right device is your capacity, your speed, your cost, your portability, your durability, and your reliability. So here it was important that it has to be reliability can be an issue. That means that if you use it that much, it might get destroyed. But in this case, it is just being used for backing up data. Let's look at the third scenario. An international game studio wants to distribute its new release for the latest games console. This could potentially involve many millions of copies being sold, so the device would have to be extremely portable and cheap enough to produce so that the company do not make a loss. Now, what gives it away is this: cheap enough. This is where it gives away what sort of device you should use. The device needs to be durable enough to withstand being handled regularly. Now, in this scenario, a Blu ray would be most suitable. What gave it away? Cheap enough to produce. A Blu ray disc is highly portable due to its size and weight, and durable enough because it has no moving parts. So, no moving parts. The cost is low, which is perfect in this scenario, at the cost as the company could potentially be selling millions of copies. So remember, DVD, Blu-rays, they are very cheap. They're not that expensive, and they are usually imported from Asia. So data capacity. So let's look at the capacity of data. So different storage devices have a range of storage capabilities. A higher capacity will allow greater data storage. How do you decide which storage device to use? So that was the question right at the beginning. How do you decide which storage device to use? How do you calculate the storage requirement? How do you find that out? Which storage device is the right for what purpose? When you know how much data you need to store, you can decide which storage device would be most uh, appropriate. So as long as you know how big a storage device is, you can make a decision. You have 300 gigabytes of data to store. Is optical storage appropriate? If not, why not? What could you use instead? Why is this particular device appropriate? So these are the questions you need to keep in your mind when you're doing these sort of questions. Which device is most appropriate for what purpose? So that's why look at those three scenarios and highlight, go over them again and see. So here is an example where it is saying Jamie wants to send his mom a copy of his wedding photographs through the mail. there are a lot of photos totaling 2 gigabytes. So they've given you what is the amount is 2 gigabyte of data. So now this is where you have to look into these their capacity. So if we go back to uh, this one where it tells you what their storage capacity is. Obviously, nowadays the capacity is much higher, and you can look on the net for the latest capacity available to put the notes down. So that's what it is saying. So the capacity, what the photographs total 2 gigabytes. So what have you need to look at? You need to look at its cost first thing per gigabyte. Then you need to know, first of all, you have to look at the capacity because that's what it is saying 2 gigabyte. Then the cost, then the access, then the speed, then the durability, then the reliability, then the portability. So it needs to be tough, it needs to be light. Which type would work? So in this case, if I was you, I would pause the video and think before you look at the answer. In this case, a USB or a DVD would be the right answer. Okay, the USB can handle 2 gigabytes of data. Next question is, Maya has made a video game and wants to distribute it to her paying customer. So as we looked at in our previous slide, we need to look at our capacity, cost, access, speed, durability, reliability, portability. So what would be the answer for that one? It would be an optical or a DVD-R in this scenario. Let's look at another scenario. Anna is a videographer and has a large collection of videos to save. Recommend a device for Anna. It would be hard disk drive because it has high capacity. Other thing which you must remember is to how to calculate these. So as I said to you earlier on, um, 1 gigabyte can be 1002. Okay, so the examiner will accept that, or examiner will accept 1024 megabytes. And CD has a capacity of 700 megabytes. DVD has 4.7 gigabytes, and Blu-ray has 25 gigabytes per layer. A Blu-ray is typically made of 4 layers. Okay, so remember that. So let's look at certain examples, some few examples here. So for example, if you were going to calculate or store a 50 by 3 minute MP3 track, how would you do that? You would do this by, first of all, you are going to divide or multiply 50 by 6 megabyte, which will give you 300 megabyte, which will easily fit on a CD-RW. So similarly, if you had to store a 90-minute MPG video, you would do 90 multiplied by 50 equals to 4,500 megabytes or 4.5 gigabyte, which would require a DVD rewritable. Okay, so let's do a bit of comparison between different devices and different scenarios. So we will look at hard disk, we look at solid state, we look at optical, okay, and we will look at these sizes. So we have got a Word document which is 246 kilobyte. We have got a photograph which is 342 kilobytes. We have got a music MP3 8,485 kilobyte, and we have got a video movie which is 62,896 kilobytes. So let's look at different scenarios. So if we had to store it on a hard disk, solid state, and optical, how would it work? So let's start with our hard disk first. and we are looking at a Word document, which we looked at in our previous year, the 246 kilobytes. The Word document 246 kilobytes on a 2 terabyte hard drive. Steps: how would you do this? How would you calculate this? So, 2 terabytes equals to 2 million megabytes. Then you would divide that by 0.2 megabytes. That will give you 10 million word documents. So size 246, which we are looking at, can be saved on a 2 terabyte hard disk. Okay, so this is really important that we are comparing different scenarios. Now we are going to look at same document 246 if it's going to be saved on a solid state drive. How would we do that? We would divide 8000 MB by 0.2 megabytes. Then we would have our answer as 40,000 word documents of a size 246 kilobyte can be saved on 8 gigabyte of our solid state. Now let's look at the same document, which is 246 Word document on an optical. So we are comparing these three. We are comparing the Word document first. So how would we do this? So obviously we are looking at a CD, which is 700 megabytes. How do we know that? We have looked here. If you go up on one of the slides I showed you, CD is 700 megabytes. So if we look here, so CD would be 700 divided by 0.2 megabytes. 3,500 word documents, a size of 246 will be saved. So let's look at the photograph. So the next scenario was the photograph, which is 342 kilobytes. So we are looking at the photograph now. So we are going to look at all three solid state, optical, and magnet and hard disk drive. So let's look at solid state first. So the size is 342 kilobytes. So how would we do that? We will first of all convert that into megabytes. Then we will divide that by 4.3 megabyte. So how many photographs could be saved? 1,860 photos can be saved. Let's look at the same scenario let's look at the music for the optical drive. So as I said, the music one was, if we go back here, the music one was 8,485 kilobytes. So how would we do that? The music one, we would first of all save the MP3 8485, convert that, divide that by 8.4 megabytes, and we will have 76 music files. So let's look at the hard disk drive. And if you were going to save a movie, which is the size of 62,896 kilobytes on a 2 terabyte hard drive, we will divide that by 62.9 megabytes, and we will be able to find out how many videos we can. So in the exam, it is really important that you understand these different sizes, which storage device is suitable. For example, here, let's look at 8 gigabyte solid state to save different options. So we are looking at if we had to save a word, which is 246, a photograph, which is 4342, a music file, which is 8485, a video, which is 62896 kilobytes. How would we do this? So we would simply divide that by, so the word, we will divide that by 0.246. That will give us the answer 32,520 files is a word file. Photographs, we will do exactly the same. 8,000, because they have given us saving capacity 8,000. 8,000 divided by 4.342 megabytes, and we will have 1,842 files. Next, they have given us our music, which is 8,000 divided by 8.485 megabytes equals to 942 files we can save. And then our video is 8,000 divided by 62.896 megabytes. We will have 127 files. So they will give you this storage, and but you have to decide what is the suitable. So remember, they will ask you to show you your calculation. The other thing you must remember, so if the question, if we go back to this question, which is, hold on, which one? Oh, this one. Okay, so you have to write down 76 music files. Sometimes students just write 76. No, what is being asked is music files. So you have to write 76 music files. So you can pause the video. I won't go over this, and you can have a look and maybe try it yourself if you can calculate it yourself. I've shown you the methods how to do them, and you can try different storage devices: solid state, optical, and hard disk drive. So let's recap on optical, magnetic, and solid state. So optical is low capacity, they are slow to access, they are thin, lightweight, and portable. Magnetic hard disk drives are high storage capacity, quick to access data, has moving parts, which will eventually fail. Hard disks perform better if they are defragmented. Now, you might say, what do we mean by defragment? We will look at that in one of our later videos. Solid state, medium, is has got medium storage capacity, very quick to access, no moving parts, very reliable, no noise, low power consumption, no need to defragment, limited number of read and write cycles, expensive compared to other types of storage. Okay, so let's look at a worked example. A smart television has secondary storage. Identify one appropriate type of secondary storage for the smart television. Justify your choice. Now, there is a difference between explanation and justifying. So, how will you answer this question? Make sure to justify your choice of storage type based on a smart television. So, it is important you base it on smart television, not on anything else, because the question is about smart television. Do not be tempted to justify why one storage type is better than another. Because here the question is not being asked why is one better than the other. It's not asking you why solid state is better than a hard disk drive, why magnetic is better than DVD or DVD-R. It is not asking you that question. It is asking a different question. So it is extremely important that you read the question. Sometimes students do a brain dump. What does that mean? That means they have just read something about storage device, and they start writing about magnetic, solid state, optical. They don't read the question what is being asked. They're not asking you the question why one storage device is better than another. They're not asking you that question. They're asking you something else. The question is totally different. They're asking you why identify one appropriate type of secondary storage for smart television. So, how would you answer this question? You would answer this. You can pause the video and um, write the notes down. The magnetic has large storage capacity. Televisions unlikely to be moved. Cost to purchase is low. Device will fit in a TV, and they are obviously reliable. Solid state or large storage capacity. Television may be moved. Fast data access. Cost to purchase is low. They run quieter. They are compact. So let's look at exam question, and this is the last slide we are going to be looking at. So it says William is creating a film for a school project using a digital video camera. William transfers the videos to a computer for editing. The computer has 1 GB of storage free. So they've given you this 1 GB of storage. Calculate the number of videos that could be stored on the computer if each video was 100 megabytes in size. So they've given you the size and the store and the how much it is free. How would you do this? You can either use 1024 or 1000. I have mentioned that before. Divide that by 100, then you will have 10. Multiply that by 100 equals to 1000. That is 10 videos. It's important you write 10 videos to get the full marks on this question.